Microservices, Docker, and containers. So we're gonna start today on microservices, Docker, and containers. We'll understand. So yesterday we started this discussion about monolithic versus microservices architecture. So we're gonna start from scratch. We have given some sort of brief explanation, but anyway, we will start from scratch. So when it comes to the monolithic and microservices part, we need to understand one thing, that why we are doing it. At the core, we would like to achieve application reliability. It becomes when we convert monolithic code, which is a huge dependency kind of a situation across, as we have discussed, because all the code are packaged together in the monolithic uh, applications. We package together, and what happens that there is a huge dependency uh, because the functions are being called anywhere and everywhere across all the modules. I I hope you guys, everybody remembers this diagram. Again, I'm gonna share that. Okay, now this diagram, right? If you look at this diagram here, what I'm showing you is a three-tier application: web server, app server, and a database server. So focus on the app server where we have all the modules, where the application logic resides, all the code of application logic resides, and we deploy web server, app server, DB server on VMs, virtual machines we deploy. So that's very important to understand, that where do we deploy the monolithic applications. Mono is single, lithic means big, something like that, a large block of code. We deploy web server, app server, and database server on the VMs. On the app server, we package all the code together. Let's say if I'm writing the code in Java, all M1 has got 20 functions here in this example. Like M1 has some code, M2 has some functions, M3 has some functions, M4 has some functions. They are the code perspective, right? I'm talking from the code perspective. So we package together. So what do we mean when we say package together? There's a huge dependency. If I'm writing F1, I'm calling other functions also from other modules. Uh, there are problems, more problems because of this kind of situation. What happens that issue with one of the functions in one of the modules can impact functionality of the other modules, right? Because there's a dependency, because M3 is dependent on M1. If M1 has issue, definitely M2 will also run into issues. That's the problem with huge dependency. So the idea here is to make it independent. How do we make it independent? Just don't remove the dependency part. Don't call the functions. Split in such a way. It's very people at the architect level, the decisions are made. Let's say if the application, if they already have some sort of monolithic applications, and if the company is trying to migrate from monolithic to microservices, at architect level, these discussions are made. The decisions are made. How do we split it? We need to split these dependent modules in such a way that the code duplicacy is the minimal. Let's say if I'm splitting, let's say these four modules, I'm packaging it together. Right now, I want to split it, but upon splitting, if I find that there are 40% of the code, M1 and M2 are matching, I have to use the same code. So there is no point in creating two different modules. So the modules, the microservices, separate microservices should be created in such a way that the code duplicacy is not there. It's all about here. Just think about it, that in one server, you have all the code together and you have some subset of some code. in the case of microservices, keep it simple, subset, some small portion of the code. If you add all these modules here, you have 200 functions. I'm talking about 50 functions in each of the modules, right? And if M1, this microservice needs to communicate with M2, they can call through REST API. Like how, to give you an example, how Make My Trip calls Indigo API or AirAsia API or Air India API, right? And get the information. It doesn't mean that Make My Trip code is calling the functions of Indigo code. No, they are not called. They are two different applications. Make My Trip is a different application. Indigo is a different application. Both are two different applications managed by two different companies. That's how it is. If Make My Trip needs some information from Indigo, they will call some API, which has been exposed by Indigo guys. Could be get call, post call, put call, delete call, right? And get the information done. That's how the even a payments app, whenever we make a payment from Swiggy, Ola, Uber, right? There are so many applications that we use on daily basis. It calls the third party payment gateway, Pay, or it could be some other Visa, right? So that's how it's a third party. So all those communication happens through REST API in the backend. It's not like the code at the together. No, the code is not together. So in a similar approach, right? Within one application, if I make my trip itself, I don't want to have this sort of setup where a lot of code are put together and they're creating a huge dependency and it becomes difficult to manage. Because let's say if I'm let's say if there's a bug fix in one of the functions in one of the modules, some small bug fix. Now to deploy that, I need to build all the code together because there is only one jar file because the packaging are happening together. See, for the one small change, I have to build the entire code, package the entire code. And you don't want to an overhead, right? So just split it up. So if M1 has some issues and doing a bug fix, it's not going to impact other microservices. M2, M3, M4 can be taken independently. Right? If M1 is getting deployed, some code fix either in M1 in one of the microservices, I'm not bothered about M2, M3, M4, how they are doing. Right? So a lot of advantages of microservices, loosely coupled environment. So the next question comes, where do we deploy these microservices? The monolithic applications were clear. We deploy on the VMs. But where should we deploy the microservices? Because it's a small portion of the code only, right? Subset of the code, not a bigger code, small subset. Within that, let's say 50 functions here, 50 functions here. So within 50 functions, the functions are being called anywhere and everywhere, this within 50 functions, right? So that's the idea of this. Just make a smaller set so that it becomes easy to manage and maintain. And there are some different developers working on M1, M2, M3, M4. That's how the companies operate. Right now, the question is, where should we deploy these microservices? So to understand that, we need to understand the evolution that is happening on the infrastructure side. Right, let's understand that. Okay, are we clear on this part, everybody? I need a thumbs up or ask me questions if you have. Good. Okay. Now, where should we deploy? Right, that's the next question. So understand that part. Let's understand how the software has been, infrastructure has been evolving over the years. If you look at this, right, this is the evolution This is the evolution. I'm showing you the evolution, how from the infrastructure perspective, how where the applications are being deployed over the years. Earlier, when the software industry started, right? When somebody, I request everybody to be on mute. I'm going to mute that. Thank you. So if you look at when the software industry IT started, right? So folks were deploying things on the physical server directly because there were no virtualization concepts as such. I'm talking about um, 1980s, right? Around 75, 80s when the software evolution started. People started to develop some sort of software, some KBs, MBs of applications. There was no concept of virtualization back then. So what people did, people deployed things on the physical servers, directly on the physical servers. There was no concept of virtualization. So we wasted a lot of resources. The idea of infrastructure optimization, efficient utilization of the resources were not there. Consider this guy as 50 cores and 100 GB RAM. And we are deploying some tiny little application, few MBs, few KBs, wasting a lot of resources. Then around 2000, a revolution came called virtualization. What did we do? People installed one sort of software on the physical server. On this physical server, we deployed some software called virtualization software. Let me get you some diagram. Okay, I should have a diagram similar to this. Let me get a diagram. Could make things. Okay, I'm gonna do one thing. I'm going to. Don't worry about where am I checking. Okay, it not go. I'm gonna check somewhere. Okay, I'm gonna put this. I'll put this image. I'll download this image. Okay, I'll put this in our Google Drive. Let me do it right away. If not, I'll forget definitely. What I'm going to do, I'm going to put this in our shared drive first. Okay. Okay, I'm uploading it here. Okay, now it will be there in your. Now please focus here, everybody. So this is the situation, right? So 1980s physical server, people were deploying few KBs, MBs applications, right, on the physical server. We were not thinking about resource utilization, efficient utilization of the resources. Then around 2000, a revolution came, virtualization. What people did on the same physical server, we installed a software called virtualization software. We have a lot of virtualized software like Hypervisor is one of the virtualization software. We have from VMware, we have a lot of softwares. Oracle has VirtualBox. Microsoft has Hyper-V, right? There are a lot of examples. So we installed a software on these physical servers, and what that did, we could virtualize the physical server and we could create VMs. VM1, VM2, VM3, VM4 of different shapes and sizes. So when we go to AWS and when we create EC2 instance, we are only able to create because virtualization has been done by the cloud service provider. AWS has already done it. That is when we go to EC2 instance and we could create VMs of different shapes and sizes. If they would not have done, we would not have created, we will not be able to create the EC2 instance. So this is the virtualization concept, right? Because after installing this, we could create VMs of different shapes and sizes, our requirement, and we could install our servers, our web server, app server, database server. We could use that. So much better, right? It was a great revolution because we were able to utilize the resources better in a much better way. Over the years, it is also found that we are not able to utilize the resources of VMs also. Mostly the VMs are like 20 to 40% utilized, maximum 20 to 40% utilized on average. So in 2015, one revolution again came. We call it containerization. What is containerization, right? And how it's related with microservices that we discussed some time back, right? So that's very interesting. So let's understand what is containerization first. So we will take one VM, right? We can go to EC2 instance, we can create one VM. We can take one VM. This is the one VM I'm showing you, VM1. We will install a software on this VM. So VM has already an operating system, right? A VM cannot exist without an operating system. A VM requires an operating system. Whenever we create the EC2 instance, we always select AMI, operating system, right? So that VM has the operating system, but we will install one more software on top of it. That software name is Container Engine. We will install Container Engine, and what Container Engine does, it will virtualize the VM and we can create containers. We could create multiple containers. So what is container? Consider like a process, dedicated process. Think like that. Let's say if this VM has 4 core. Let's say this VM has 4 core total. We can define a container with 500 millicore or 1 core. Let's say 1 core. So if this VM has 4 core and if I'm creating a process with 1 core, how many processes I can create like that? Quick answer.
4.
4, right? So this is what it does. So we could create containers. So consider like containers like a process. We could create containers, and what we will do on these containers, we can deploy the microservices. That microservices, that is a subset, right? So it is not like you cannot deploy the monolithic on these containers. Everything could be deployed, doesn't matter. Containerization is a technology that in VMs we can create containers and deploy some application. You can also deploy monolithic applications. That's fine. Anything could be deployed on a container, but mostly we deploy the microservices. That's what we do. So we would create containers as per the capacity of this VM. So the idea, what is the idea? The end result is efficient utilization of the resource. That's the main objective. And what we will achieve by doing the efficient utilization of the resources, what we will achieve? What is the main focus?
Cost optimization.
Come again?
Cost optimization.
Cost optimization. Yes. That is the main objective. Without compromising on the scalability or on the application functionality, if we could do the cost optimization, That's why this is great. This technology is so popular, so much adoption across the IT world, across the IT community, because this technology is able to reduce the cost by 50% by doing the VM approach. So you can ask like why we can deploy containers, we can deploy microservices. Let's if you require, so you can say like, OK, so you mentioned that microservices are subset of the bigger code. That's good. So why can't we get from 4 code, create a VM of 1 core and deploy microservices? All those things could be done. But this is a technology. And using this technology, we get a lot of other features also, which those features were not there in VMs. We will come to those features when we'll talk about Kubernetes. We will talk about the features that a container gets. It's a great technology. That's why it's popular. So what we're going to do, we will take a VM. This VM has an operating system already. We will install a software called Container Engine. One of the popular container engine is Docker. We will install Docker on this VM. And then we could deploy the microservices. Multiple microservices. I'll give you one of the simplest example, okay, to make you understanding better. Let's say if I require 3 VMs. I require 3 VMs for my web server, app server, database server, right? I can run all the 3 applications in one VM by creating 3 containers in it. Think about it. I require 3 VMs to run my web server separately, app server separately, database server separately. 3 VMs I require. Let's say 4 core each or 8 core each. Let's say 8 core each. So how many total cores I have used? 24? Yes. Now I can take one VM of 8 core and I can run 3 containers. I can create 3 containers. I understand that in one container, in one VM, I can create 3 containers. There's no doubt about that. Maybe one VM 8 core is not enough. That's fine from a resource perspective. But if I create one more VM and if I spin up more containers in that, two VMs could be enough for my to support the same workload. So eventually I am doing the cost optimization by reducing the core's requirement. Core is the most costliest part. Core is what is the costliest. The core, the process, the CPU, right? In your laptop, what is the most costliest thing? The processor. Cores cost the most. Right. So the idea here is this. So we will take one VM. We will make sure that this VM is fully utilized. We will create 3 containers, one for web server, one for app server, one for database server. And we will make sure that the VM resources are fully utilized. Then only if I require additional core, I can create another VM and I can deploy the same microservices. The idea here is the efficient utilization of the resources. That is the main objective. And what we'll achieve? We'll achieve the cost optimization. Okay. Does that sound good? Why this? What is microservices and how microservices and containers are related? Any questions? Able to understand, guys? Need a thumbs up from you so that I understand whether you understood or not.
Sir, one question from my side.
Go ahead.
So if the container is need to add more capacity, so that can be extended further. We are saying like 3 containers. So out of 3, one has a demand wherein we need to extend it further. So can I just keep extending one container?
I will create more such containers.
You'll create more such containers. Okay.
Let's say app server needs more containers. I need app server is having the contention. I may have one web server right now to start with. I have one web server, one app server, one database server. I can create, if I have the resource in the same VM, I can create one more app container.
Okay.
If I don't have, I can create one more VM and I create more app containers. Horizontally scaling, we call it horizontal scaling. There are two things from the scalability perspective. There are two things, horizontal and vertical. Vertical is like increasing the same capacity, right? Let's say if I have one core defined for one container, I'm replacing that one core with 2 core, or I'm replacing 2 core with 4 core. That is called vertical scaling. But if I have one core of one container, and if I'm creating 2 more such containers, that is called horizontal scaling.
Okay.
So we can do horizontal scaling of the containers if that's the requirement.
Okay. Okay. Fine.
Okay. So now let's do this demo part. Okay, let's do this demo part. So what we're gonna do, we will create VM. So we'll create VM. So this diagram would make things better for you. Understand this. So what are the advantages of containers? Better performance, uh, resource efficiency. It will boots up in seconds. It's a very lightweight. It boots up in seconds. Takes fractions of disk and memory. These are the characteristics of containers. They are the advantages of the containers. We are talking about container engine, which is Docker. We'll install Docker in the VM, and then we could create containers. So let's understand how containers work. What I'm showing you in this diagram, in this left diagram, is the virtualization, normal virtualization. This is the physical server, and I am installing hypervisor. I'm installing hypervisor. Right, let me use this. Okay, what I'm gonna do, I'm not gonna do any color thing here. I will use the laser pointer. Okay, so this is the physical server, and I'm installing some sort of virtualization software. Hypervisor is one of the softwares, virtualization softwares. And then we could create VMs. This is VM1. This is VM2. This is VM3. Every VM has the guest OS. You know that. Without VM, without OS, a VM cannot be created. Every VM has the guest OS. This is normal virtualization, VMs. This is VM1. I have installed application 1, application A in VM1. I have installed application B in VM1, VM2, and I have installed application C in VM3. On the right side, I'm showing you about the containerization. So I have taken one VM. It's a one VM. We already have the host OS, like same as guest OS. We already have the host OS. What we're going to install on top of it? A container engine. Docker. I can install other container engine also. We have Rocket, we have Container D, we have other lot of container engines option, but Docker is the most popular one. So on this VM, we will install Docker, a container engine, and then we could create container 1, container 2, container 3. Okay. Keep this diagram. Okay, I'll come back to this diagram again. So let's understand the technology. When we create the containers, it is like a mini VM. Containers are like mini VM. In one VM, you will feel that you have multiple VMs. Remember my word, what I'm told you. Containers are like mini VM. Inside one VM, I will get one vCPU, 1 GB RAM of a VM I will create now. And in one vCPU, 1 GB RAM, I can create multiple containers. And each container would feel like a mini VM. You know why it will happen? Try to understand this. This technology is different. The virtualization is happening because in virtualization, the virtualization of physical server is happening because we are installing the server here. In the virtualization, the hypervisor, the virtualization softwares virtualizes the physical server. This is the technology in virtualization, but in containerization, the Docker, the container engine virtualizes the host OS. It installs the OS because since it virtualizes the host OS, the same OS can be leveraged by all the containers. You may not understand this completely what I'm saying, telling you. I'm going to show this to you. Then you will appreciate this better. OK, so what I'm going to do, I'm going to do a hands-on. I'm going to create a VM. The VM will have the host OS. And I'm going to install Docker on top of it. And then I'll create such multiple containers. Then I'll show you. I'll come back to this. OK, let's do that. So I'll connect to the cloud. Let me create a VM. I'm calling it anything. Ubuntu. I'm selecting my operating system. So this is the operating system, AMI. I'm going to keep it T2.micro. T2.micro. 1 vCPU, 1 GB RAM. Usually we don't do this in production. At least 4 core. So that we can create multiple containers. But even in 1 core, 1 GB RAM, you will see that I could create multiple containers in 1 core itself. Okay, so I'm keeping it T2.micro. I will select a key pair. Okay, I'm going to keep it default. Let's not use. Let's just keep it default VPC. Let it be. I will select some security group. Okay, let's say. Keep it like this. Okay, 8 GB. I can use 8 GB of disk. Since I have exhausted the free tier, just to optimize the cost of AWS instance, I'm going to use spot instances. Spot instances are the ways to optimize the cost. If when you have exhausted the free tier, okay, I'm going to do that. So it will not give you any you know about spot instances, right? I must have told you about just for the cost optimization. In the spot instances, you get the maximum discount. AWS offers you the maximum discount. Only problem is that you cannot use it for the mission critical applications in production because AWS can take it back. But they give you 90% discount as compared to the on-demand instances. Okay, from user perspective, it doesn't make any difference at all. Okay, so I have my server. This server has a OS, Ubuntu OS. I'm gonna SSH to this server. I'll use MobiX to SSH. Okay, I have got the keys here. Hopefully security group is not a problem. Good, I'm able to connect. Okay, I got connected. I could SSH to this AWS EC2 instance, and this has the OS installed. I'm going to update the package. Okay. It may be the root user and do it. Okay, so I have got the OS. I have got the VM with me. What I'm going to do as per the plan? Do I have Docker installed here?
Here updating package means like initial configuration or
Updating package. I'm going to give you the best example. Have you done Windows update?
yeah.
Same thing.
Okay.
In Linux, that's called updating the package.
Okay. So every time when we log into this server, we
Nothing like that. Do you do Windows update every time?
No, sometimes by automatically those will get updated.
Correct. So we don't need to do every time because I logged in, I created this server for the first time I did that.
Okay. Yeah.
So updating the packages is like Windows update. Yeah. So all the packages that we have got the latest version. That's all.
Okay. Yeah.
So do I have Docker installed here?
No.
No.
I'm going to install Docker. Apt install docker.io. Okay. This is the command to install Docker in the Ubuntu VM. And hit enter.
How do we know it installs the latest package?
Again, can you repeat your question?
No. I mean, if we want to specific to some versions, can we install that with the version number, or it downloads the latest version and installs?
Correct. You just download the latest version. So if you're asking, can we specify it? Yes, you can, but there are so many packages. Which one will you specify? So in general, I have done it because this AMI, AWS has created long time back, right? They may not have the latest thing, Ubuntu latest thing, latest packages, right?
No, I'm talking about the Docker one.
Okay, you're talking about the Docker one. You can specify, yes, you can specify, but when you do this, what happened that it gives you some version. So if you look at this, it has installed 24.0.5 version. For client, Docker has this client and server communication. So it has installed 24.0.5, one of the stable versions. If you want to specify some other versions, yes, you can specify that. So if I show you the Docker latest Docker versions, latest, it may not be 24. This is the official website of Docker, docs.docker.com. This is the official website of Docker. You can find the Docker latest version here, release notes, and you can find the release notes about Docker. 26 is going on. 26. Okay, 26.0.1 is the latest one. So you can install if by specifying the version, but it may not be the stable version, maybe the beta version. So when I used Docker IO, when I have not given, it has just given me the 24.0.5 version. Gonna be the stable version, but you can update. You can download the. You can make sure that you can download this or 25 or 26. You can do that. Does that answer your question?
Yes, Roshan, thank you.
Okay, sure. Okay, so now I have got Docker installed. So when I see the version, Docker version, it has two things, the client and the server. The Docker architecture is like this. It has the client server kind of architecture. So I'll show you. So if I show you the Docker, this is the Docker architecture. So you have the client. In the client, we issue commands. And that's what in the client we do. So Docker version, I'm issuing this in the client. What happens when I issue the commands in the client? The request goes to the server, which is Docker daemon, through REST API. So whatever I type through REST API, the information goes to the Docker daemon, which is the server. And then this guy is the brain. This guy does all the things, whatever you are asking the client, from client, the request is coming. Whatever is being asked, being asked to accomplish, to do, this guy does that, right? So the request from the client goes to the Docker daemon through REST API. This guy processes all the information and gives you the output back. So when I type this command Docker version, the same thing is happening. If I type another kind of command, Docker info. So again, a lot of information has coming. Do I have any containers running? No. Do I have any containers running? 0, right? Do I have any containers paused, stopped? How many images we have? 0. So it has all the information. So I'm typing this kind of commands in the client. The request is going to the server through REST API, server processing information and giving me the output back. That's what the communication happens. And that's why when I type Docker version, you get these two details about the client and the server. Docker is developed in Go language. That's why you see this Go version, because Docker is written in Go language. Okay. That's why you see this. No. Okay, I have got everything set up. I have got my VM. I have got Docker installed. So I'll come back to this diagram. So everything is sorted out here. I have got the Docker installed already. So what I should do, I should create containers and deploy the microservices. So I need microservice code, right? Whatever the microservice. So usually the microservice comes in the form of image, We call it container image. So even if a developer, let's say developer is working on some microservice. So what we should ask from developers, or what developers would give us, developer would create an image, container image, right? And when I get the image of that microservice, I will run that image to create the container, right? Then I can stop it, start it. Let's understand about the Docker container lifecycle. Let's understand this. Let's understand this diagram. So I have got the Docker engine with me, Docker engine and client. I have installed. I have this with me. I need an image from somewhere where I can pull the image from somewhere. Or if I'm creating the image, I can push it to somewhere. So since we're talking about Docker hosts a lot of images from different companies, from different vendors. And there is one very popular website. Usually a lot of images are hosted by different companies, different products in Docker Hub. Docker Hub is a very popular website which hosts a lot of images, container images. Again, now don't think that container image could be only of microservice. No, I don't want you to think this. It could be also, it could be the microservice. Container image could be anything. It could be a monolithic application. It could be an operating system. Because image is image, it could be anything. It could be microservice. It could be anything. It could be Jmeter also. It could be Jenkins also. Image is image. It could be anything. I want you to understand this. Though we are talking about microservices deployment, but understand that this is independent technology, containerization. This technology is not only for microservices. I can run Jmeter also as one of the container. My process could be anything. I can run Selenium as one of the container. I can run anything as a container. Image could be anything. It could be a microservice. It could be monolithic. It could be an operating system. It could be any software. What is important? Do I have image of that or not? If I have that image, I can run that application, that software as a container. Docker would help us on this. So what I'm showing you here is the Docker container lifecycle. I have installed this Docker engine. A lot of companies have hosted the container images in Docker Hub. I'll go to this website, very popular website. So I told you one of the website called docs.docker.com. This is the Docker is the company name also. Docker Inc. Docker Inc. is the company name. And docs.docker.com is the official website of all the documentations. All the documentations. So docs.docker.com is very popular. If you want to know any information about Docker, go to docs.docker.com and search for it. Whatever, go to this website and search. Get Docker guides, manuals, references. You get any kind of information in this docs.docker.com. Whatever you want to know. Docker Hub link is also there. So I'm going to the okay, leave it. I'll go to the hub.docker.com. I told you about docs.docker.com. All the documentations could be found here. You can find all the documentations here in the docs.docker.com. You can search for anything. You will get it here. In the you can consider this as repository for all the Docker related documentations, informations. One place where you can find anything, any information about Docker. Now, this is docs.docker.com. Let's come to the hub.docker.com. Again, very popular. So a lot of companies, a lot of products, they host their container image here. Let me show you. Let's say web server, Apache, right? Apache, apart from Apache, very famous web servers are there. I have shown you earlier how to install Apache 2. If I want to run Apache 2, I can install Apache 2 in a VM also. In a VM, I can use Apache 2. I can install Apache 2. If I want to install, let me show you. I have a VM. This is a VM. I want to install a web server. Apache 2 is the web server. Apache 2 or HTTPD, whatever you can say it. Let's say Apache 2 is the web server. I can install a web server here on this VM. That's called VM installation. Or I can run Apache 2 as a container also, because I have HTTP. If I search HTTPD, I have as a container image also. HTTPD or Apache 2 both are same. HTTPD is also available as a container image. Docker official image. Apache official image means the company has put this. So I can install Apache 2 in a VM, or I can run as a container. Both the things could be done. We are talking about containers. If I want to run as a container, I will use this. I will get the image from this. I will issue this command. This issue will download the image. I'm going to show you both the approaches, installing on a VM and running as a container on a VM. So this is the image. To get the image, Docker image, I can issue this command, Docker pull HTTPD. This will pull the image. Do I have any image right now? If I type Docker images, do I have any image right now? I don't have any images. I can issue this command, Docker pull HTTPD. This will download this image. Similarly, like HTTPD, we have got Tomcat. If I want to run Tomcat as a container, I have the image with me. Official image. If I want MySQL database to run as a container, I can install database on a VM, or I can run database as a container also. I have MySQL official image database. So I showed you one web server, Apache 2, HTTPD. I showed you Tomcat, which is like a application server. I showed you MySQL. Like similar, you have MongoDB. You have got a lot of softwares like this. MongoDB, Mongo, official images, Docker official image, MongoDB. If you want to run just Jmeter, fine, Jmeter will be also there. Somebody would have downloaded this. Jmeter. This is Grafana. Jmeter also could be fine. Jmeter. Anything could be run as a container. That's what I'm trying to tell you. Not just the application, but I also have operating system as container image. Let's say Fedora. I have Fedora as the container image. Anything could be run as a container. If I want to deploy microservice, okay, I will ask the developer, my developer working in the team, okay, give me the image. And I can run that as a container. Fine. Or I can run these things as a container. Anything could be run as a container. Okay, now focus on this part. So I have Docker Hub where I have a lot of container images. I can push also. If I have some image with me, I can push also. pull you guys showed, right? Docker pull. If I do pull, yeah, Ashok, what is the question? Go ahead.
Yeah, so I mean, what is the benefit of this image? Is it because something is
You
readily
can create.
available, you're
Okay.
making use of it, or?
Okay. Do you think benefit of container?
No. I'm talking about Docker images.
Yeah. I got your question. I'm asking you another question.
Okay. Sorry,
Do
what
you
was that?
think containers are useful?
Yes, it is.
So you answered your question. We will use Docker image to create containers. So I'm not sure if I answered the question. You asked, right, that why we use Docker image. Correct?
I was thinking like it would be a direct install on the virtual machines, the Docker engine. Then you picked up this Docker images topic, right? I'm just trying to correlate that. Is it?
No. Okay, see, why we install Docker? Without installing Docker, you cannot create containers. Is that clear?
Yes, yeah.
Without installing Docker, we cannot do that. So we install Docker. You are with me, right? So far.
Correct.
Now, how will I create container? I need some software, right? I need something, some binary, some image with me, right? To create to a microservice binary or some binary to create containers and deploy that image, deploy that binary, deploy that, whatever it is. So I need something, some software that I need to deploy, right? So that's the image.
Okay, got it.
Okay, now what I'm going to do, just to make it clear, I gave you an example of HTTPD. Let me do that. Okay, I'll go to the hub.docker.com and I will, for HTTPD, let me download the image. Okay, I'm going to issue this command, docker pull HTTPD. I'm before doing executing this command, please confirm, do I have any images with me right now? Docker images is the command to check. No. I'm going to, I'm doing the copy paste, docker pull HTTPD. Now I'm going to hit enter. What this guy will do, this guy will download the image in my VM from Docker Hub. Done. If I type Docker images now, do you see an image?
Yeah, it's created.
Not created, downloaded.
Downloaded, yeah.
I'm not creating it, just downloading.
Okay.
I don't have any container running now. Docker ps is the command to check containers. Do I have any containers running?
No.
So don't worry about all the commands. I have pasted all the commands, okay, for your reference. Just follow along and you have all the commands. So just keep on. So Docker ps is the command to check the running content. I don't have any container running. I have the image with me. So I need image to create containers, right? So let's come back to the discussion of Docker container lifecycle. So I got the images with me. So when I run this image, I will get the container created. And why are we creating containers? Are we clear that why are we creating containers? Do you think it's justifiable? Have we justified why we need containers? Okay, let's see if somebody asks. I can install anything on a VM. Why do I need to run as a container? What would you answer?
Cost optimization, one thing, and easily manageable. You are efficiently using the resources.
Right.
Mm-hmm.
That's the answer. Right. So that's what we're talking about. So this is the process to create container. And Docker, we have installed Docker. Because if you don't install Docker, Docker pull command will not work. Docker run command will not work. Docker command will not work. So we need Docker to create containers. That's why we installed. Right now we have just the images with me. I don't have containers. I need to run the image to create the container. Docker run is the command. If I want to run the image, I need to use Docker run command. Docker run command. When I run Docker run, when I use, it creates the container. So let me show you. Let's say I'm gonna install HTTPD as a container also, right? So let me do one thing. First, I want you to understand this. See, if once you understand, right, you will love this. But if you don't understand, you may not appreciate this so much. So what I'm doing, I have this VM. I can install HTTPD or web server directly on the VM. I can do that. This could be done. I can directly install this. So two approach. I can directly install this in a VM, or second approach, I can run as a container. Two approach I have. So HTTPD, since I am working in Ubuntu, we call it Apache 2. Okay. So I'll just name it Apache 2. Both are same. Okay. Just, or I can run HTTPD as a container. Both I can do. So let me show you both so that you understand the difference well. This is a container. This is a VM. So let me do this first part. I am going to directly install Apache 2 on a VM. Fine. Let me do that. Directly install. Let's not worry about containers right now. How would you have installed a software on the VM? So apt install Apache 2. This command can install a web server on the VM. I'm not using Docker run here. This is going to install web server on the VM. Okay, done.
And here that download whatever Apache 2 we are installing, right? It will take from the downloaded one, or directly it will have somewhere.
It takes from apt package. Apt is the package manager, right?
Okay.
It looks like you have not installed anything on a VM. So apt is the default package manager in Ubuntu. If you work in Red Hat, yum is the default package manager. So that package manager, it downloads from that app from app package manager.
Okay. Yeah. Thank you.
I have not. It's not pre-downloaded. It is downloading on the fly from the package manager. Now I have installed. Let's understand how to check which port this web server is running. How to check? If I ask you, I have some application running in some port in a VM, Linux VM. How will you check all the ports? Nobody? I have shown you a couple of times, right? Nobody's answering. You can use netstat command or lsoft command. Both commands could be used. OK, let me use one of the commands. OK, this is going to print all the ports running in this VM. So you can see this 53 is for the DNS name, port 22 is for the SSH. And then you can see this port 80 Apache 2. So where Apache 2 is running, which port?
80.
Port 80.
80.
Are we clear? You can
Yeah.
use netstat command also. It will work, give you the same output. OK, so port 80. Now let's access this web server because I have installed web server. It will give me a default page. Right. How can I access the web server? At port 80. So what I should use? Public IP colon
80.
port. OK. If this output is not coming, what could have gone wrong? This is not coming up. What could have gone wrong?
It's
That
not
network
open for others to access.
Come
network
again?
setting.
Network settings.
You
I
didn't
mean,
allow.
not
Yeah,
open
that
for
port
public access.
we need to open under the
Where?
security group. Sorry, yeah, under the security group.
Let's
Yeah.
open port 80. Do I have port 80 open here? Do I have port 80 open here?
No.
Need to open port 80. I have opened port 80. This is the default page. This page is coming from my server. OK, I'm going to give you this link. Even you guys can access this. Can you guys confirm the link which I have given working for you as well? Yes, no? I've just pasted the link in the
You
chat.
gave a HTTPS, but if we do HTTP, it works. Yeah.
OK, no. OK, HTTPS. Sorry, HTTPS. I have not opened it. Sorry. Do HTTP.
Yeah.
Yeah, I have not opened. If you look at the security group, I have not opened HTTPS. Do
Yeah.
HTTP.
HTTP is
Yeah.
working.
Yeah. I have not opened HTTPS. OK. Working, right? HTTP? Yes, because I have opened only HTTP. Fine. So this is the normal installation. This is the normal installation in a VM. In a VM. I can go to this. This web page is coming from this index.html file. I can go and I can access this. Fine. But this is a normal installation. And I can have hundreds of index file with me. I can write HTML, CSS, JavaScript. I can come with hundreds of pages. I can have my own website. All I need to is point this website to my DNS name, abc.com, and my website will be up and running. Web server. This is what web server does. So what I have done here, I've installed web server on a VM. Is this running as a container?
Yes.
No,
Is this
this is
running as
not.
a container?
No, this is not container.
This is not container. You can see this Docker PS, nothing. No container running. Now, what I'm going to do, I'm going to use the image that I have downloaded. Docker images. I have got the images with me. I have got this image, HTTPD image. I'm going to use this image to create the container. Let's run as a container. So Docker run is the command. OK, Docker run. Docker run HTTPD image. I can hit enter, but there are few things that I need to do. Whenever you run a container, we should always do -itd. Okay, -itd is for the interactive detached mode and TTY terminal. Okay, just know that we should always do this. This is a web server. You access this from a website. Do I have public? When I installed the web server on the VM, I have the public IP of the VM and I could use it to access the web server. Now I'm running HTTPD. I'm going to run a HTTPD as a container. Do I have? Will I get public IP of the container? Will I get public IP of the container?
No.
There is only public IP of the VM only. There is no public IP of the container. There is nothing such thing public IP of the container. No. So how can I, even if I run this, even if I create this container, which is the web server, how will I be able to access? That we need to take care. Right? So since we don't have public IP of this container, what we do, we rely on we can hit only the host, the VM. So we have to do something called port mapping. I have to create a bridge because eventually I have to hit this guy because all my web pages, all my web server is here. So I need to create some sort of bridge between the container and the VM. Some sort of bridge, because I can only hit the public IP of the VM. I have only that. Yeah, Ratnas, Prashad, container will have its IP, but will that be public IP? How will you access this? That's the question, Ratna Prashad.
Okay, sir. So my question is also basically, so can we assign an IP to a container or not possible?
No,
It's
no.
not that.
Public IP you cannot assign. You get public IP of the VM only.
Okay.
You can
So the
containers will
entire
have
VM,
IP. They will have
right?
private IPs.
So a VM has multiple containers, which means every container is referred through using same IP, right?
If they
But
are
however,
public facing.
public facing. Okay, okay.
If the containers communicate with each other, all containers will not be public facing, right?
Right. Okay.
Web server and interacting with app server, app server interacting with database server. They are not public facing. They can communicate using private IP.
Right, right. Okay. Okay, sir, got it.
So for the containers which needs to be accessed from the internet, they have to do this. We have to do this for them. If the container one, this is container one, this is container two, container three. Container one, container two, for them, I did not do this. They can communicate using private IP because every container will have IP.
Yes, sir, I got it.
Yeah. I'm just trying to for others. Okay. Now this is the web server. I don't have public IP of this. This is the web container. I don't have public IP of this. So I have to rely on the public IP of the host, the VM. So that's why we have to do port mapping. We call it port mapping. So I have to access this guy, but directly I cannot do that. So I will do a port mapping. So by default, when you create the container, okay, so now understand this thing, very, very important. When I installed HTTPD, which port we installed Apache to on this VM? Just now we did. Which port we did?
80.
Port 80. So remember this now. Gonna be very interesting now. Okay, don't lose the focus. If not, you'll get confused. Now, by default, even containers run on port 80. It is in the image itself. I will show you. If I do docker inspect container, I'm not going to use this command right away. I have the image with me. I'm going to do docker inspect HTTPD, the container, the image. You will see that in the container image, port 80 is only configured. It's in the image. We cannot change it. We can change it, but leave it. Here's the default ones coming. Port 80 only. So this container will run on port 80 only. That's fact. We cannot change this because it's in the image. Now, when I do the port mapping, we have to make sure that we use the available port of the host. Can I use port 80 right away? Right now again, or of the VM? Port 80 is already being used. Can I use again port 80 of the VM?
No, it's not free. Port 80.
Exactly. So I have to use any other port. I can use 81 or 82 or 80, 80, 90, 90, any available port I can use. But I cannot use right now port 80 because it's in use. If I would not have installed this software, I could have done port 80 also. But right now I cannot do this because port 80 is already been used. I cannot run two applications on the same port. Okay, so I'm going to do port mapping like this. Okay, 82 port of the host. Okay, now how do we do Docker run? Very interesting. So Docker run HTTPD is the image. I will always use ITD and for port mapping -p we use. And the syntax that we use port mapping, we have to first give the port of the host. So 82 port maps to 80 port of the container. I hope it makes sense. We have to give this syntax. The host of the port colon port of the host first thing and then port of the container. We cannot change this 80 here. It's in the image. We cannot change this. 82 we could have changed any available port 81, 80, 80, 90, 90, whatever it's available port I can use. So far so good. This is how we create containers. It's a web server. It is the internet facing public facing container web container. That's why I'm doing port mapping. I need not do port mapping for every container. If it's a Tomcat or it's a database, I need not do this port mapping every time. Port mapping is only required when you have to access publicly using the public IP. Okay, I'm going to hit enter. So if the moment I do this, you see this Docker PS, one container running. So this is what happening. This is what happened. I have got this container running. And how can I access this container? Public IP of the host colon. What to give? Please tell me.
82.
82. Do I have 82 open in my security group?
No. Oh.
I don't have. I have to open to access. I have opened port 82. Now I can access. Public IP, the IP colon 82 port. This page is coming from the container. This page is coming from the container. I can show you. Okay. Does it make sense for all of you? Whatever I demonstrated for now. Is everybody on the same page?
Yeah, if this port 80, right, for Apache we right now using, if it is free, then we can match
You
with
can
the
use, yes, we can do port 80 colon
80.
80 also.
Okay,
Yes.
okay.
I have a question here.
Come again.
Yeah. So when you created a container, you just created it. You did not specify its memory or what CPU it needs to
Yeah,
run.
I've
Like
not done it. I don't want to complicate things. You can do that, right? By default, it takes some resources. Yeah, you can specify that as well. We'll come to that. So let me show you, since you asked this question. If you go to the docs.docker.com, the website, the popular website, go over the Docker run. I'm going to ask you to go explore the Docker run command. Docker run command has got. OK, I'm going to give you a link. OK, 1 second. I'm going to give you a link. OK, now I'm going to give you this link. I'll copy this link to your one of the the 1 hour GitHub location, right? We have used it. Let me paste that link there. I'm going to give you this link. So keep this handy in the AWS links. I'll simply put important links. Docker run. So just refer this link. OK, let me show you this link. What this link has. This link has all the possibility that you can use the Docker run. Since you mentioned about CPU quota, you can give CPU quota. CPU percentage. How many cores you want, you can add. These are all the attributes we can use the Docker run. Not just CPU, you can also give memory -m. If you use -m option, you can give memory also. Right now, I have not given this just to make things simple for you. I don't want to complicate that command because it's the first time you guys are learning about Docker run, but you have all the options here in the Docker run command that you can use. You can give how much core you want, how much memory you want. You can do this. OK. Now, this is the container created. Are we all on the same page, everybody? I'm going to assume silence as we are all right. If not, ask me questions. I have tried my best to make things simple for you, but still, if you have not understood, do let me know.
No, it's okay, sir. It's clear.
OK, good. Now, I told you that this particular website, this particular output is coming from the container. right? I told you this. It works. Let's understand from where it is coming. Let's understand this. So to understand this, what we should do, we should go inside the container. So let's go inside the container. I have got the container ID with me. What we can do, we can go inside the container. So docker exec is the command. Exec is the command to go inside the container. Docker exec -it container ID bin bash. This is the format to go inside the container. Please focus on this part. The moment I hit enter, you will find a different kind of this. You will find a different kind of this. I'm going to hit enter. What do you guys think? Where am I right now? Root at the rate of this. This was the VM. And root at the rate of container ID. I'm inside the container. Yes or no? I'm inside the container. And I told you, remember I told you something that the container feels like the mini VM. It is the mini VM. It is the separate world. Though I'm in a VM, 1 vCPU, 1 GB RAM virtual machine. I created the container. I'm inside the container right now. Don't think that I'm in a VM. If I type Docker version, do you think will it work? Do I have Docker installed in the container? What do you guys think? Will it work? Docker, if I type Docker version, will it work?
No.
So,
No, it should not work.
right? Because I have not in it is a separate world. I have installed Docker in a VM, not inside the container. It will not work. It will doesn't even understand. It is a separate world, but it is Linux only. Yes or no? I have root, everything. It is a Linux only. Doesn't tell me, doesn't it feel like that I'm inside a VM? Separate VM. I'm not inside the host. I'm inside the container. And I don't have the same software which I've installed at the host. It's a totally different world. And it feels like I'm in a VM. It is a separate environment. Containers are a separate environment. Able to understand what I'm trying to tell you guys? Because why? Remember the technology. Remember this diagram when I was explaining you. The Docker virtualizes the host OS. That is the difference here. Since the container engine virtualizes the host OS, I can leverage the same host OS by all the containers. That is the reason. I can leverage the host OS by all the running containers. That's the beauty of container. It's a separate world. Right. Let me show you where that web page is coming from. If I go inside CD USR local Apache 2 htdocs, if I go inside the htdocs, I have an index.html file. If I cat this index.x, if I cat this index file, this it works is coming from this page. If I change this, it works, right? My web page will change. This is the location of the index file in the container. Under USR local Apache to htdocs, this is the location of, I can have again more index file and I can have my different web pages. It does feel like a separate operating system, separate. Have you guys noticed the size of the image? I'm going to do exit. I'm going to come out of the container. I'm going inside the VM now. I'm inside the VM. Have you guys noticed the size of the image? Can an operating system can come in 148 MB? Can you create an operating system in 148 MB along with web server HTTPD? Is it possible? It is only possible to give us a feel of a separate OS or as a separate environment because the container engine has virtualized the host OS and all my containers are leveraging the host OS. In 148 MB, it's not possible at all to have a separate OS. I don't have a mini OS. I don't have an OS here. Like in the case of VM, I don't have OS, but my containers does feel like VMs, separate VMs, mini VMs. Did we get this part? I need a thumbs up or to wait so that I understand you have understood. Knowledge any way possible. Nodding your head, I cannot see that. Good. Now let's do one thing. Let's install some software inside the container. Let's go that. I was already inside the container. Let me go inside it again. I'm inside the container again. I'm gonna change this, the htdocs. Let me go inside the htdocs. In fact, I'll tell you one thing. In fact, the VI command will not work here. The container image has the bare minimal things. VI will not work here inside the container. If I type VI right now, index, it will not work. Containers, that's why 148 MB. In 148 MB, it has the bare minimum thing. What is required for a web server to be up and running? That's what I have. If I want to VI, I have to install something. Let me install apt install vim. I need to update the, what happened? I'm not able to install this guy. If I update this. Okay, let me update this apt update -y. I'm going to update the package first. Then I'm going to install apt install vim. Okay. Sometimes these things works with the updated packages. Okay, so I have installed vim now. What I can do, I have done two things. I have updated the packages and I have installed vim in the container. So I can do vi now, index file, and I can go and check it works just fine. I'm going to add something. Just want to tell you that just fine. So I just added something. So do you think my website will change now if I refresh this page?
Yes. Yeah.
Not changed. Okay, now let's come out of the container. Exit is the command. I'm inside the VM now and I have the container running. Okay, I have the container running and I've installed some software. Let's let's save the image. I have done some installations right on the container. Let me save the image. So docker commit is the command. Docker commit container ID. And I'm going to give the new image name. Let's say HTTP HTTPD new something. This is how I can save the image. I'm going to hit enter. This will create a new container with the latest code, whatever I have downloaded and installed. So if I type Docker images, how many images will you see now? Quickly, guys. If I type Docker images, how many images will you see now?
Two is to be.
Two images. One was HTTPD, which I downloaded, and another one is HTTPD new.
Yeah.
What do you think will be the difference in these two?
Size will be different.
Yeah, exactly. Exactly. The new has got more size. Why?
We have done some updates and
Correct.
over there.
Exactly. Now, if I use this container image to create the container, in the new container image, will I have Vim installed?
Yes.
Yes. Yes, I will have. So Docker commit is one of the ways to create the image. Right? Like, so I have one container right now. I can create another container. Let's say I can create another container. Let's say Fedora. Fedora is the operating system. I can use Docker pull Fedora. This will download the image of the Fedora. It is the CentOS distribution, Linux distribution. I'm downloading this, so I have got images downloaded. If I type Docker images, I have got the Fedora. I can run Fedora as a container. So Docker run. I did not do -p this time. Docker run -itd would be enough this time, and Fedora. This would be enough. I did not do -p here. Docker ps. If I do, you can see that I have got two containers running. Since I have not give, I can also give the name. Name is one of the attributes. I can give it Docker run command. Since I'm not giving the -n name, it's taking some random name. Okay, so you can see this Fedora is also created. I have got two containers created. If I want to check how much resources they are taking, I can use Docker stats command. Docker stats command can help me know the resources being taken by the two containers. You can look at this. The CPU, because I'm not using the container, so the CPU utilization is 0, and memory utilization is very less. Right, Docker stats is the command to check the resource utilization. So containers takes a lot of less resource. Right now, if you hit the web server, right? If you everybody try to hit the web server, I may get some CPU utilization, more CPU utilization on the web server. Look at the name. I would say the name of the web server is youthful bug, whatever they have. This is the second. The last guy is my web server, and it has taken some memory. Right. If everybody will hit the web server, I will get some CPU utilization. Right. So what did we learn today? We learned about how do we create containers? How do we deploy microservices? That's what we learned today. I don't want to overwhelm you guys now. Anything more? I'll just stop it here for any Q&A if you have.
Roshan, here, right, we have done the port mapping where we use the 82 port, which is free for now we use for this container. So like if we are creating multiple container, then we need to find out different ports, or in case of web servers, we are making the multiple container in the same VM.
Okay, see, I'll tell you first thing in production usage, right? Coming to production, we don't run as a container, right? Like this. We will use Kubernetes and we use load balancers, right? We use those kind of things. So we'll come to that. But to simply answer your question, if I have, let's say, multiple, I will have multiple web servers, right? Right? Not just only one. So if I have only one, I can use only one port, right? And in case if I have multiple web servers, right? So I will always try to use a load balancer kind of a thing.
Okay.
We will explore this, see, because it's not like a VM. Okay. So you will understand this. How do we work on this? See, it's not about only one VM, right? I may have another VM also, right?
Yeah.
I may have another VMs and my containers would be located across the VMs also. And then what I should do? I should do a load balancing.
Okay, that load balancer concept will come. Yeah. Okay.
So yeah, I would say just don't worry about much right now. Let the topic happen for Kubernetes.
Okay.
Then we'll understand this better.
Okay.
For now, just try to keep understanding the concept of container.
Okay.
About the production usage, when we come to Kubernetes, we'll understand it better. Because multiple VM, it will not be one VM, it will be multiple VMs. And containers will be deployed across multiple VMs. Right? So let's say I have got three, just to give you some idea. So let's say I have got three containers here.
Okay.
For three containers, I have different IPs. Correct?
Yeah.
Because the public IP will be different. For to access this container, one IP, for this container, one URL, for this container, one URL. Because even if the port is common, port 80, my IP is changing, right? My public IP of all the VMs are changing, right? So tell me now, I have got three URLs now. Which URL will you give to the customer?
We need to use the load balancer concept.
Load balance, exactly. So to answer your question, the port could be same since all the containers are same. It is of same type. So if the containers are of same type, port could be same. No need to use different ports. In fact, the IP will change.
Yeah.
And then we need to use a load balancer to access all these containers.
Okay.
We'll discuss this later.
Okay. Thank you.
Roshan, to reiterate what you did, one question.
Go ahead.
So to reiterate what you did today, you installed you created on virtual, installed actually HTTPD on a virtual machine, and also you installed on a container, and also installed one more container with Fedora, correct?
I installed first of all, created a VM. I installed web server on the VM. Then I created a container, right? And then I showed you how do we access that container, port mapping and all. Went inside the container to show you that how containers behave. right? We took the Docker commit also. We saved the latest image. We created another container also. Showed you Docker stats for the utilization of the containers in a VM. These 4 or 5 things we did today.
Just want to, if I want to try on my end, just want to
Yeah,
reiterate.
definitely you should try that. If you don't try it, you'll forget.
Yeah. Can you just write on high level steps alone, like what are the steps?
Can you write, Vijay? Can you write? Let me ask this to you. Can you write it here right away in the chat?
Okay,
I just
I'll
told
try.
you.
Okay. Yeah, I will try.
Right, 1, 2, 3, 4, 5 steps. And you can copy these steps. Everybody can copy that steps.
I'm trying now.
Let me do this. It'll take longer.
Yeah, but you're right.
Yeah, just do these steps. I can write you something more. Okay, I have done it. So you can copy paste this. Those you want to explore can copy paste. Okay, guys, thank you so much. We'll meet. So please practice. We'll meet next week and discuss further. Thank you so much.
Thank you, Rush.
Thank you.
Thank you.